Hi everybody. This week we're going to be talking about reciprocal trigonometric functions. So that is kind of a review of some things we've already learned, but we are going to be incorporating the reciprocal trig functions. So let's please recall the regular functions. So we have sine of theta. And just as an aside, remember that is theta. That is what we use to represent angles. It is a Greek letter, theta, T-H-E-T-A. So sine of theta, that was our opposite over the hypotenuse. Then we had cosine of theta, and that was the adjacent over the hypotenuse. And we also had tangent of theta, and that was the opposite over the adjacent. The way that the reciprocal functions work is, hopefully you remember, reciprocal is just a fraction where the denominator and numerator switch places. So what the reciprocal functions are, there is cosecant, and we abbreviate that with CSC of theta, but you would still say cosecant theta, don't say CSC. And that is the reciprocal of sine. So that is going to be the hypotenuse over the opposite. Okay. Then we have cosine of theta, and the reciprocal of cosine is what we call secant, and that is abbreviated SEC of theta, so secant of theta, and that is the reciprocal of adjacent over hypotenuse, which means it is the hypotenuse over the adjacent. The last one is tangent. This is maybe the easiest one to remember because it is just cotangent, and we would abbreviate that COT of theta, so cotangent of theta. And again, it's the reciprocal, so it is the adjacent over the opposite. To me, the way that I kind of remember these, and I hope this helps, sine and cosine, there's a S and a C, cosine and secant, an S and a C, so they don't match up. It's not like sine goes with secant, sine goes with cosecant, and cosine goes with secant. And then tangent is obviously pretty easy because they both still have the word tangent in them. So these are the reciprocal functions that we are going to be using. Please write them down somewhere. You need to have them nearby, unless you already memorize which is what, and you can easily flip them in your head. What I'm going to get into next is just reviewing some special right triangles. Okay, you guys, here are some special right triangles. You learned this in Math 2, but just as a quick review, a 45, 45, 90 degree triangle is indeed a right triangle because obviously 90 degrees is one of the angles. Both angles are 45 degrees other than the 90, and the side that is opposite of the 45 degrees is A. So it's just one of whatever the value is. And the one that is opposite of the right angle, the hypotenuse, is A times root 2. So the hypotenuse is whatever the side length is times root 2. If we go over to the 30, 60, 90, across from the 90 degree angle, which is the biggest angle in the triangle, we have the biggest side length, which is 2A. The smallest angle is 30 degrees, and the one opposite of that is just A. And then the medium angle, 60 degrees, is the medium measurement, which is A root 3. So we are going to be using these special triangles to solve for our 6 trig functions in a right triangle. So please get this down in your notes or have a picture of it nearby. I'm going to be referencing them, and it is how we are going to be solving for our trigonometric functions. So please keep them nearby, otherwise you might get confused. All right, what we are going to do is we need to find the cotangent of 30 degrees. So if you notice, I redrew my special right triangle on the side. And what we're actually going to do for all these problems today, and you'll really see why next week, is we are going to set the hypotenuse equal to 1, which hopefully you can see I have already done over here. My hypotenuse is 1. I'm going to fill in the other parts from my special right triangle. So we know that the hypotenuse was supposed to be 2a. The one across from the 30 degrees was just a, and across from the 60 degrees was a times root 3. So to actually solve this, to find the cotangent of 30, first of all, I know that my theta value is going to be 30. So I am going to be dealing with this angle up here. So what I'm going to do is I am going to label all of my sides, either hypotenuse, adjacent, or opposite. So hypotenuse is always the same across from the right angle. The opposite of my 30 degrees is the A value over here, and my adjacent is the one right here. Okay, now when we're talking about finding cotangent, remember that is the inverse operation of tangent. Reciprocal operation of tangent. So cotangent of theta, whatever the theta is, that is going to be the adjacent over the opposite. So I know now that I need to have my adjacent and my opposite. In order to do that, though, I have to figure out what value that A is and then plug it in. So I actually have my adjacent and my opposite. So the way that we actually do that, I'm going to do that down here in the corner. We know based on the hypotenuse is a measurement of 1, and that is 2a. So I need to solve for a. Hopefully you can figure this out. Divide by 2 on both sides, and we get a equals a half. So what I'm going to do is I'm going to now re-plug that in. So that means that my adjacent side, my opposite side, and I just realized I actually labeled that with an H. That should be an O for my opposite side. My opposite side measurement is a half, and my adjacent side is a half times root 3, also known as root 3 over 2. So I know that the adjacent side, so let's get that written over here. My adjacent side is root 3 over 2, and I know that my opposite side is 1/2. So what I'm going to do, I am simply just going to plug those into the ratio and then simplify. So I know that cotangent of 30 degrees is going to be my root 3 over 2 over 1/2. Hopefully you guys remember how to solve a complex fraction like this. You flip the denominator and then turn it into multiplying. So what it ends up being is root 3 over 2 times 2 over 1. Hopefully you see what cancels. And when we multiply through, we end up with a root 3 over 1, which is the same as just root 3. So cotangent of 30 degrees is root 3. I know that that's a lot of steps. Maybe rewatch this again if you need to. Basically, I labeled my triangle, and then I know that the hypotenuse is 1. Again, that is given to you. You guys will be using that more next week. And this is just kind of getting us in the practice for the hypotenuse being 1. So hypotenuse is 1, so I went down to the square in the corner, solved for A, plugged that in for A, and then substituted those values into my reciprocal ratio, so the adjacent over opposite, and then just simplified. I'm going to give you guys one to do, and then you can pause it. The next problem is finding the cosecant of 60 degrees. I'm going to let you guys pause it right here and find that. I put the triangle already up there for you, so go ahead and get started, do that, and then come back when you're done. To start solving this one, I need cosecant of 60, so that means I'm going to be dealing with this angle right here. So because of that, I'm going to label my sides. I know that this would be my opposite. The adjacent is the one touching it, and the hypotenuse is always the one across from the right angle. I am also now going to plug in the stuff from our special triangles. So across from the 90 degrees is 2a, And remember, the hypotenuse is always going to be 1 for these examples. The one across from the 60 degrees is a times root 3. Be careful you don't get that a mixed up with the adjacent a. I'm using different colors. I hope that helps. And the one across from the 30 degrees we label as just a. So again, like last time, I am going to now solve for a. So I have 2a equals 1. I hope this looks familiar because it's still a 30, 60, 90 triangle. We get a equals 1/2. So again, plugging it in to all the other values. On this side, I get my adjacent is 1/2 because it's just a. And I get that my opposite is a times root 3, which is the same as root 3 over 2. I'm now going to come over here and just write my general rule for cosecant. So cosecant of theta, remember theta is what we use. Cosecant of theta is my hypotenuse over my opposite. It's the opposite, it's the reciprocal of sine. So what I'm going to need to do to find cosecant of 60 is I'm going to need to fill in my hypotenuse and my opposite. So the hypotenuse is 1 and my opposite is root 3 over 2. So I'm going to have a 1 over root 3 over 2. And again, we are in one of those situations like we were in the last problem with a complex fraction. So what that is going to turn into, it will be 1 over 1 times, and then the denominator flips. So 2 over root 3. Clearly that times 1 is just 2 over root 3. Now there is a problem here that we learned last unit. We're not allowed to have a radical in the denominator. So what I'm going to have to do is rationalize. So times by root 3 on bottom, times by root 3 on top. And when I do that, I get 2 root 3 over 3. So that means that cosecant of 60 degrees is 2 root 3 over 3. Hopefully you guys got that or somewhere close to that. Hopefully you are on your way to it. Hopefully you also remember to rationalize the denominator. I'm going to give you guys one more and then you guys can start your book work. And here is the last problem. Find the cosine of 45 degrees. I have the triangle there for you. Go ahead and start to solve it, and then you can pause the video. When you come back, I'll have the answer for you. I really do suggest you guys pause the video and try to solve these on your own. It's the best way that you're going to be able to learn to really do these and to get them, for yourself. And this process that we're doing is going to get a bit more complicated next lesson. So please make sure that you're following along and you're able to do it with these, basic triangles. It will really, really help you for next week. So please pause now and then start solving. Okay, this is what you should have got for your answer. Going through a few things. If you used on your triangle the other 45-degree angle, you should still end up with the same answer because it's a 45, 45, 90. Doesn't really matter which one you use or how you orient it. I used the highlighted one that I did on mine. So I labeled my adjacent opposite hypotenuse. I labeled the sides A, and A times root 2. And then I went through down to the bottom corner and I solved for A, divided by root 2 on both sides. Then I rationalized it and I got root 2 over 2. So I went back up here to the top and I replaced my A with root 2 over 2. And we already knew the hypotenuse was 1 because, like I said, we are assuming the hypotenuse is 1 in every single one of these questions. Please do the same thing on the bookwork, the classwork, and the mini test. This also lets me know who is watching this and who is actually listening to what I am saying. Hypotenuse needs to be 1. So then what we do is I wrote out just the general, format. Cosine of theta is adjacent over hypotenuse. From there, I plugged in what I know. I know theta is 45 degrees. My adjacent is root 2 over 2, and my hypotenuse is 1 because, again, always assume the hypotenuse is 1 for this week. It will help you as we move forward. When I do that again, a complex fraction, I flip the bottom 1 over 1. It's just root 2 over 2. So for my final answer, I get cosine of 45 is root 2 over 2. Again, you guys, I hope this lesson makes sense. I know some of them are kind of weird. If you weren't comfortable with radicals, I can definitely see how you might struggle with this one. Just remember the only radicals we're going to be having, though, is root 2 and root 3 because we're only dealing with these special triangles. So please go ahead and do the bookwork 7.3 right after this. Again, assume the hypotenuse is always 1. Then you can do the classwork tomorrow. If you have any questions, bring them Wednesday to our Zoom check-in. And then on Thursday, you will have the mini test on this lesson. Yeah, let me know if you guys have any problems, all right? Hope you guys have a good Monday.